Hello everyone! We are going to go over some new worksheets today and get ready for our next lesson, so here is what you need. Okay, so by now you should have finished lesson 15 homework and we're going to go over the next few problems together. Starting with number 1, Miguel glues a ribbon border around the edges of a 5-inch by 8-inch picture to create a frame. What is the total length of ribbon Miguel uses? So right now I know a rectangle is 2 pairs of equal sides, so I'm going to draw my rectangle with the 2 shorter sides being 5 inches and the 2 longer sides being 8 inches. When I did the perimeter addition, I added the like numbers first. So I did 5 inches plus 5 inches plus 8 inches plus 8 inches. When I combined those, I got 10 inches plus 16 inches. And when I combined those, I got 26 inches. So now I know that Miguel uses 26 inches of ribbon. Number 2 says, a building at Elmira College has a room shaped like a regular octagon. The length of each side of the room is 5 feet. What is the perimeter of this room? So a regular octagon has 8 equal sides, and each side is 5 feet. So I did 8 times 5, the number of sides times the length of the side, and I got 40. So this way I know that the perimeter of the room is 40 feet. Number 3 says that Manny fences in a rectangular area for his dog to play in the backyard. The area measures 35 yards by 45 yards. What is the total length of the fence that Manny uses? So even though the problem says the area of the shape is 35 yards by 45 yards, that means I know that 2 sides are those because area is length times width. If it's a rectangle, then I know that there's 2 short sides are 35 yards and the 2 longer sides are 45 yards. So again, I'm going to add up the like numbers first. So 35 yards plus 35 yards plus 45 yards plus 45 yards, which turns into 70 plus 90. When I add 70 and 90, I get 160. So I know that the total length of the fence that Manny uses is 160 yards. Tyler uses 6 craft sticks to make a hexagon. Each craft stick is 6 inches long. What is the perimeter of Tyler's hexagon? So a hexagon has 6 sides, and if each side is 6 inches, so 6 times 6 equals 36. Tyler's hexagon has a perimeter of 36 inches. Frances made a rectangular path from her driveway to the porch. The width of the path is 2 feet. The length is 28 feet longer than the width. What is the perimeter of the path? So I hope you paid close attention that the length is 28 feet longer than the width. So if it's longer, I'm going to need to add that to the width. So when I draw my rectangle, one side is 2 feet and the other is going to be 30 feet because it's 28 feet longer than that 2 feet. So I'm going to add the like numbers, 2 feet plus 2 feet plus 30 feet plus 30 feet. And that's going to change into 4 feet plus 60 feet, 64 feet. The perimeter of the path is 64 feet. The gym teacher uses tape to mark a 4-square court on the gym floor as shown. The outer square has side lengths of 16 feet. What is the total length of tape the teacher uses to mark square A? So I know that the outer square is 4 equal sides, and each of those sides is 16 feet. I see that they're split in half with the different squares inside, so each of those tiny side lengths is 8 feet. We're just focusing on square A. So I've labeled all the sides of the square, and each side is 8 feet. So if there are 4 equal sides of 8 feet, I'm going to do 4 times 8, the number of sides times the length of the side, which equals 32. So the teacher uses 32 feet of tape to mark square A. Alright, now go ahead and get the lesson 15 exit ticket ready in front of you, and then the timer will begin. You'll have 4 minutes to do this on your own. Do as much as you can. If you finish early, you can skip past the timer. If you don't finish, don't worry about it, and we'll go over after the timer. Awesome job finishing. Okay, let's go over the exit ticket. Marlene ropes off a square section of her yard where she plants grass. One side length of the square measures 9 yards. What is the total length of rope Marlene uses? So, if I know a square, it has 4 equal sides. If I know that one side length is 9 yards, I know that all the side lengths are 9 yards. So I'm going to do 9 times 4. I did the side length times the number of sides. 9 times 4 equals 36. So Marlene used 36 yards of rope. Now remember, mine looks a little bit different for the application problem because I didn't have the digital copy, but it should look pretty much the same as this one. So go ahead and get the application problem, and when you're ready, we are going to go over it. Gail places 2 regular hexagons side by side as shown to make a new shape. Each side measures 6 centimeters. Find the perimeter of his new shape. So what I did was when these two hexagons are together, I put a little dash mark on each side of the outside. Notice how I did not put a dash mark on the 2 sides where they meet up, because that is on the inside of the shape. We are focusing on the outside of the shape as that is the perimeter. So let's count how many marks we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 sides. So, an easy way to do this, there are 10 sides in Gigi's new shape. If each side is 6 centimeters, I can easily do 10 times 6. So the perimeter of the shape is 60 centimeters. Now we're going to go over the Lesson 17 problem set. These might take a while, and you can always pause them because it's something new that we're going to explain, and I'm going to break it down with each problem. Okay, let's go ahead and look at number 1. As you can see, it has the dotted line splitting this shape into 2 smaller shapes. So what I'm going to do is I'm going to use that to label the side lengths. So at the top there's 2 centimeters and the bottom is 4 centimeters, which tells me that the side length I'm going to fill in is going to be another 2 centimeters on the top of that smaller box to fill in the side lengths. Then what I'm going to do is I'm going to look at the 3 centimeter side. On the opposite side, there's a 2 centimeter length. So now I know that that small side, that's going to be 1 centimeters. So, finding the perimeter, you're going to measure the outside of the shape. So as you can see mine, I have filled in the 1 centimeter and the 2 centimeters. I got those from looking at the opposite side lengths and seeing what I had to fill in to complete the sides to the same length. I wrote down all the side lengths. 2 centimeters plus 1 centimeter plus 2 centimeters plus 2 centimeters plus 4 centimeters plus 2 centimeters. To make this easier for myself, looking at it, I noticed that I have 2 centimeters 3 times. So in parentheses, I wrote 3 times 2 centimeters, and then I'm going to add the rest because those are unlike numbers. So 3 times 2 centimeters is 6 centimeters. I combined 1 and 4 to make 5, plus 3 centimeters. When I add all those up, I get 14 centimeters. So this is something new. If you're confused, pause it, go over it again. Basically, you're looking at the opposite sides to fill in the blank sides, and we're adding up the outsides. I found the like numbers in the addition, so I created that multiplication problem. Now looking at B, I can see that that top side length is 5 feet. So I'm going to know that the bottom side length also has to add up to 5 feet, where that little box is taken out. It already has 2 feet, and 2 plus 2 is 4. I add 1 more to get 5 feet, so I know that that top length of that little empty square is going to be another foot. The side length is another foot because it's a square. So again, I'm going to add up all the outside numbers. 2 feet plus 5 feet plus 2 feet plus 2 feet plus 1 foot plus 1 foot plus 1 foot plus 2 feet. I notice that the same numbers are repeated a few times. There are 4 2 feet and there are 3 1 feet. So I put in parentheses 4 times 2 feet plus 3 times 1 foot plus 5 feet. 4 times 2 is 8. 3 times 1 is 3, and I still have my 5 feet left. When I add all those up, I'm going to get a perimeter of 16 feet. Alright, let's go ahead and look at C. I put the little dotted lines to split it into the 2 different shapes. So, if I'm going to look at my tall shape, and the bottom, one side is 6 meters, and that little tiny side is 2 meters. So I can tell that the top of that shape is also going to be another 2 meters. Then, on the side, 2 meters is already there, so I know that top shape and the dotted line I created are 2 meters because 2 plus 2 plus 2 equals 6 meters, the same as its opposite side. Now, my horizontal rectangle where one side is 4 meters, I'm going to know that the top of that is 4 meters, and I already found but the dotted line is 2 meters, same as of its opposite side. Again, I know this is confusing. If you can pause it, look at the problem. You're basically trying to make sure that they match the total of their opposite side. So once I add up all the outside, not the dotted line that is on the inside, once I add up all the outside, I get 2 meters plus 2 meters plus 4 meters plus 2 meters plus 4 meters plus 2 meters plus 2 meters plus 6 meters. By now, I hope you found the pattern that when you see the same number multiple times, you can put them inside parentheses to do a smaller multiplication problem. So, for instance, 2 meters was written 5 times, so that's where I got the 5 times 2 meters. 4 meters was written 2 times, that's where I got that multiplication. So 5 times 2 is 10 meters, 2 times 4 is 8 meters, and I still have that 6 meter side. So I have 10 plus 14, and I get the perimeter of 24 meters. Now D is a lot to look at, but if we break it down, we're good. So let's label the top. Once I've broken that dotted line down, I know that it's a square. So 2 sides are 2 yards by 2 yards, so I can easily label the other side as 2 yards, and that dotted line is 2 yards. That's my top shape, a little square with every side as 2 yards. We're good. Now looking at that dotted line, to make the next larger rectangle, I know that I can create these. So if that yard length is 2 yards, I can realize that the other smaller side is 1 yard because the bottom dotted line is 3 yards, which we'll explain in a second. Now, I also can tell that the side lengths are 2 yards and 2 yards because when I look at the larger rectangle on the bottom, the longest length is 7 yards and there's 2 yards and 2 yards on the top. So 2 plus 2 is 4. I need 3 to get to 7, which is where that dotted length of 3 yards comes from. I know the opposite side of 2 yards is still going to be 2 yards, which is where that side length comes from. It's a lot to add up, but when you break it down, it's going to be 2 yards plus 4 yards plus 2 yards plus 2 yards plus 7 yards plus 2 yards plus 2 yards plus 2 yards plus 1 yard plus 2 yard. That's a lot. So I can see that 2 yards was written 7 times, which is where that multiplication problem comes from. I still have 7 yards, 1 yard, and 4 yards left. So 7 times 2 yards is 14 yards. I added up all the outside numbers to get that 12 yards. 14 plus 12 yards is 26 yards. All right, now we have moved on to number 2. Nathan draws and labels the square in the rectangle below. Find the perimeter of the new shape. So the new shape, we're going to have to find the perimeter of the shaded and the unshaded. So let's go ahead and look at the unshaded figure. I know that one side length of the unshaded is 12 centimeters, so I'm going to know that the opposite side on the top is also 12 centimeters. The shaded figure is a square because that's what it says in the instructions. He draws a square. A square has 4 equal sides. So if one of those sides is 6 centimeters, each side is going to be 6 centimeters. So what I did was I added all the outside lines up. So 6 centimeters plus 6 centimeters plus 12 centimeters plus 6 centimeters plus 12 centimeters plus 6 centimeters. I noticed 6 centimeters was written 4 times, so that's where I got the multiplication from. 4 times 6 centimeters, and I have 12 centimeters and 12 centimeters on the outside as well. 4 times 6 centimeters is 24 centimeters. 12 plus 12 is also 24. So I'm going to end up with 24 centimeters plus 24 centimeters, which adds up to 48 centimeters. So the perimeter of the shape is 48 centimeters. These are a little bit confusing, but if you're lost, when you break it down, you're going to just make sure that the side lengths when you're labeling are equal to the opposites, because these are regular shapes. All right, our last problem for the day, and I know it's been a lot. Label the unknown side lengths, then find the perimeter of the shaded rectangle. So even though we're going to label all the different side lengths, at the end, all we have to worry about is the side lengths of the shaded rectangle. So let's look at the big rectangle at first, so including the shaded. We need to find the label for A. So let's look at A. If I know the one next to it is 8 inches, and if I look down, the bottom length is 16 inches, I'm trying to find A. So I have to add something to that 8 inches so that that whole side length would also equal 16 inches. And that's where I got the 8 inches from. Because when I add both of those sides up, I'm going to get 16 inches because it has to equal the same as that bottom side. Now if I look at the side length labeled 7 inches, I know that the opposite side length is also going to be 7 inches. but I only have 2 inches labeled. So I had to find out what plus 2 equals b. So I figure out that b equals 5 inches, and knowing it's a rectangle, I can label the other side lengths because they are equal. So now I find the perimeter of only the shaded rectangle. I am going to do 8 inches plus 8 inches plus 5 inches plus 5 inches. 16 plus 10, and that equals 26 inches. So the perimeter of the shaded is 26 inches. Awesome job with this lesson. I know it's been a lot and it's something new, but you can always go back and rewatch this video, pause it whenever you need to, and look at your homework helper. We will go over the lesson 17 homework in our next video.